Hello, my name is Adam Stevenson and I'm the Segment Manager for Downstream Oil and Gas at AkzoNobel. This short presentation will look at the Matcote system, the products used and the application of that system. This presentation is intended to include the most up-to-date information, but as with all coating systems, application guidelines and product data sheets can be updated at any time, and as such, it's always best to consult the latest product literature. The presentation itself will cover off a number of different areas, including a brief introduction to linings, an introduction to the Matcote system and the interline products used, how to prepare surfaces, the application of the system, and how to undertake quality control, technical inspection, and repair procedures. So first, let's have a brief look at an introduction to linings. So why do we need to line tanks and use linings such as the Matcote system? Well, a lining is a barrier between a solution and a substrate, and all linings must be suitable for the operating environment of the tank. That's both against the cargo inside the tank and any climatic or atmospheric conditions outside the tank. A lining must provide protection against corrosion, as examples, crude oil tanks, the bottom and roughly 1 meter up the side, against corrosive chemicals such as aqueous solutions, against contaminants in refined products, and also the move towards biofuels has led to increased issues with steel corrosion. A lining must also provide environmental protection. Some studies have suggested over 7 million US gallons or 26.5 million litres could be lost each year in leaks in just in North America alone. And also protection of product purity. So this is the lining of whole tanks to prevent contamination against rust particles and so on. And if the correct surface preparation, application and lining system is not used, a range of problems can be seen, including corrosion, blistering, discoloration and delamination, or general failure of the coating system. There are a number of key elements to consider when deciding which lining system to use. First of all, what is a substrate? Is it steel or concrete? Second, what is the condition of that substrate, good or bad? And this will lead you down to a choice of thin or thick film or matte reinforced schemes. Of course, the final element is the chemical, which is the cargo in the tank, and for that you need to refer to specific chemical resistance guides. Steel metal loss on tank floors is a major problem to storage facility owners. Long-term storage of crude oil with a water bottom phase can contribute to major steel corrosion and can result in severely pitted steel tank floors. Historically, full replacement of the floor plates was generally considered to be the only solution. However, an alternative solution is the use of an interline spray-applied glass fibre reinforced laminate system. This laminate system is also referred to as the Matcote system. We'll now move on to the Matcote system itself and the interline products used within that system. The Matcote system itself has been around since the 1950s and was thought of as an alternative solution to replacing steel plates. It was originally created within AkzoNobel and was spun off by a group of their employees. The system has been used to protect tanks since 1962. Many hundreds of thousands of square meters have been applied in that time. The Matcote system itself is the application of chopped glass fibre in combination with a high build 100% solids epoxy phenolic material, typically Interline 984. The Matcote system has a number of benefits against traditional methods, the main one of these being the speed of installation. Traditional trowel-applied thick film systems might have an application rate of 5 meters squared per hour. Hand-layer laminate systems might have 20 meters squared per hour, but the Matcote system can be applied at up to 60 meters squared per hour. And what this means is that a 72 meter diameter tank can be completed in 10 days with a Matcote system, versus 30 days or more with a hand-layer system. The typical use of the Matcote system is on crude oil or petrochemical tanks under maintenance. This does not preclude its use at new construction. However, its main use is on heavily pitted or poor quality steel floors. The coating product or resin at the core of the Matcote system is Interline 984. Interline 984 is an ultra high solids, low VOC epoxy phenolic, typically applied in 2 to 3 coats in the 1400 to 2000 micron range. It's got immersion resistance to a number of petrochemicals up to 90 degrees C and has superior abrasion and impact resistance. It's also compatible with cathodic protection, has good thermal and mechanical shock resistance, and has a long history of successful applications in storage tanks. The Matcote system itself is 100% spray applied. The chopped strand or glass fibre roving is applied simultaneously with the resin or the Interline 984. A special dual head chopper gun is used to apply both the 984 and chopped strand together. The system is then rolled to eliminate air and consolidate the laminate. The Matcote laminate fills pitting in steel tank floors, including Omega pits, and the Matcote laminate has market-leading hole bridging capabilities. I've mentioned over the last few slides the role the Matcote system has in repairing tank floors. On the previous slide I mentioned about Omega pits. You can see on the screen here what an Omega pit looks like in comparison to an open pit. The picture on screen demonstrates how the Matcote system fills and follows all pit contours, both open and Omega pits. This is achieved through a combination of spray application and rolling to ensure each pit is completely filled with the epoxy material. I've talked already about the hole bridging capability of the Matcote system, and the chart on screen shows how the Interline 984 and chopped glass fibre system, or the Matcote system, can deliver hole bridging capability of up to 180 mm in an 18 metre tank. This is to tackle the scourge of underside corrosion. So far we've talked about linings themselves and also the products which are used in the Matcote system. Now we move on to the personnel required to make sure the Matcote job is a success. First of all, there needs to be 2 people at the pump, one manning the controls and the second ensuring the materials are refilled as they are consumed. Next, we need both a sprayer using the gun and also a lineman behind the sprayer. The role of the lineman is critical to ensure that the line does not become a hazard for the sprayer as he walks backwards during application. Then we need around about 4 people on rollers providing different services to ensure that the Matcote system is fully embedded in the resin. The 9th position is one of the most critical and is an inspector to make sure the Matcote system as applied meets the specification. This includes wet film thickness measurements and also to ensure that the material is not applied too wet or too dry. Remediating any issues whilst the material is still wet is much more efficient than trying to repair systems after application. And as with all tank applications, there needs to be a watcher to ensure there's no HSE issues. We'll now move on to the surface preparation required for the Matcote system. So firstly a question, why do we properly prepare surfaces? Well, it's to remove surface contaminants, it's to promote adhesion of the coating to the substrate, and it's to reduce any likelihood of premature failure of the system. Some of the key considerations when looking at site requirements include cleanliness, as contamination can cause premature failure and moisture ingress causes degradation of any prepared steel. Making sure that the power source is sufficient for compressors, for blasting and spraying, for ventilation to maintain a safe working atmosphere, for lighting to ensure good visibility, for dehumidification to maintain climatic conditions, and for heating to maintain steel temperatures. It's also critical to ensure that the storage facility is on site to ensure that the paint temperature is maintained and if any preheating of materials is used, that this can be done on site. As with all working tanks, ventilation is very important. Here's an example table in the working procedures for Interline 984. However, the critical thing to remember is always extract lower than the air input. This will ensure that as the heavy solvents fall to the ground, they're extracted safely and working can continue without any potential of harm. In addition to ventilation, it's very important that the right personal protective equipment, or PPE, is used when applying the Matcote system. To minimize risks, exposure should be minimized through the use of the correct PPE. Risk assessments should be carried out by a suitably qualified person. An individual project or specifications may call for additional activities or precautions to be taken. However, typically, this would include the right mask, a hard hat, the right gloves, safety glasses or goggles, coveralls, a disposable suit, safety shoes, and maybe earplugs. As with all protective coating systems, surface preparation is key to ensure the Matcote system has the best chance of long-term performance. A number of expectations around surface preparation are in place, including a minimum SA 2.5, a profile of 50 microns minimum, but ideally 75 to 100 microns or 3 to 4 mils, low levels of salt contamination, and if higher levels are found, a fresh water wash and a reblast may be required. It's also important to ensure that the blast itself is done with the right pressure and the right grit. On this slide you'll see a picture of a steel plate and the repairs undertaken to it. You'll also see that the repair area itself has been ground back to ensure there's no sharp areas and no weld spatter. And as previously mentioned, ensuring that the right blast is undertaken and the right cleanliness is achieved is key in the long-term performance of the system. Once the blast has occurred, it's important to ensure that the whole area, that is the whole tank, is cleaned correctly. This means that all spent abrasive has to be removed, and ideally all surfaces will be vacuum cleaned to ensure they're dust free. In addition, the next step would be priming. An application of the correct primer can be used to maintain the blast. Now we'll move on to the application of the Matcote system itself. Just before we move on to the steps of the application itself, it's worthwhile looking at the overall specification for the Matcote system. So we've already talked about the blast and the profile that's required. We also briefly mentioned the primer, but moving on from that, there's also a caulk, so Interline 921, and this can be used for heavily pitted areas, and it can also be used for bash plates and other weld seams and stripe coating. Then there's the Interline 984, which we've talked about previously. So this is the solvent-free resin, which the glass fibre laminate is then embedded into. The next step is to sand the laminate to remove any wicks, and then the laminate is sealed with another 350 microns of Interline 984. This is basically a gel coat. So the total system is roughly around 1600 microns or 64 mils. One of the most important questions we get asked is around the material usage for each step in the system itself. So when considering material usage, you can use the following estimations. So for the caulk, for Interline 921, so it's roughly 0.5 litres per metre squared, though obviously this differs widely depending upon the condition of the steel, if it's riveted and so on. The laminate itself at 1200 microns is 1.78 litres per metre squared. The gel coat at 400 microns is 0.5 litres per metre squared, and the actual usage of the glass fibre roving is around 300 grams per metre squared. So from that you would get about 55 metres squared per roll. And to flip that around onto the production rates, so an experienced team during a full 12-hour shift could caulk around 1200 metres squared in a day, could laminate around 750 metres squared in a day, and can gel coat around 1500 metres squared a day. As I've mentioned, this is an experienced team in a 12-hour shift. So first of all, the primer. Our recommendation is 125 micron or 1 mil coat of Interline 982. Now with a blast profile of 50 to 100 microns, this will not cover the full blast profile, and you may see some gingering of the steel. However, in our experience, this still provides the best surface for the laminate system to be applied. Other options are available, but please contact your local lining specialist to discuss further. As with any protective coating system, stripe coating is an essential part of any lining specification. Stripe coat should be applied to all areas which are difficult to get the required coating coverage on through typical application methods such as airless spray. This includes plate edges, welds, pipes, ladders, and difficult access areas. We would normally advise that a stripe coat is applied via brush, and failure to do effective stripe coating can lead to weak areas where early failure of the coating system does occur. After application of the primer, the next step is to caulk any areas requiring caulking. Our specification requires the application of Interline 921 for this end use, and the caulking compound is applied to all welds, protrusions, and such like areas to ensure a smooth transition for rollers and to aid application of the entire system. And of course, stripe coating of the caulk may be required as well. On this slide you'll see two photographs. On the left, the applicator is applying the caulk to the weld, and on the right, the applicator is hand applying caulk to a large surface area due to the steel being in a poor condition. The next two slides consider the replacement of bash plates and jacking of tank legs. So as you can see here, the process is in place, and on the right, some preparation via grinding is done to the area where the bash plate is to be replaced. Moving on to the next two photographs here, on the left you can see the bash plate has been reinstalled using Interline 921 or the caulk as the glue to hold it in place. On the right hand side you can see the tank leg has been released and Interline 921 or the caulk is being used to hold the entire bash plate in place, ready for the laminate system. As I mentioned earlier, the glass fibre laminate itself uses Interline 984 and chopped glass fibre roving. Both materials are applied simultaneously using a specialised spray gun. A roller is then used to consolidate the glass fibre roving into the resin. And as mentioned previously, spray application means the process itself is much quicker than traditional hand lay. Now moving on to the specialised spray gun itself, on the left you'll see the twin spray tips which allow the glass fibre roving to be wet out completely by the resin, and on the right the safety cover has been removed and you can see the razor blades and the rubber ring which ensure the glass fibre roving is chopped. Because the chopper gun has moving parts and blades inside it, any maintenance of the chopper gun must be done under safe conditions. So there's a few key considerations when doing maintenance. Firstly, goggles or safety glasses must be worn at all times during maintenance on the gun. If undertaking any maintenance on the gun, ensure both the air supply safety and the paint gun safety are secured. If possible, undertake maintenance on a table or other suitable support. And if undertaking maintenance on a job site, the operator should kneel on one knee, resting the chopper gun on the other knee for support. Before removing the cover from the chopper gun, ensure the air supply valve is shut. If you see the picture on the right, where one gun has the air valve open and the other one shut. If removing the chopper gun cover, ensure that suitable gloves and or a material rag is used to handle the cutter head. If air must be supplied to free fibres from the cutter head whilst the cover is removed, please ensure that eye protection is worn and that all personnel are clear from the close vicinity. I've mentioned the specialised spray gun attachment a few times, and this diagram is intended to show why this setup is required. So the dual tips allow the resin to wet out the substrate first, then the chopped fiberglass is also wet out during the spraying process, and finally some of the resin will be applied on top of the chopped fibre to ensure encapsulation. One of the key steps to ensure is that the glass fibre roving is kept clean and dry. If the roving becomes wet, you will get many blockages in the chopper head. Following application of the laminate through the specialised application equipment, the next step is to use various rollers to consolidate the glass fibre into the resin system. These two photographs show the application equipment in use. As you can see, as the applicator walks backwards, he's laying down some resin first, then the chopped glass fibre, and then more resin. This slide shows two more photographs of the application process underway. On the left hand side, you may notice some matte and gloss areas as the application is taking place. The matte areas indicate areas which have not yet had the glass fibre roving consolidated into the resin, or potentially might be areas where there's not enough resin being applied. On the right hand side, you'll see three members of the team working together. The lineman ensuring that the lines are moved and not a hazard for the applicator, and one of the rollers coming back over the area to ensure that the fibre is consolidated. Once application of the laminate system is complete, it may be noticed that there's some wicks or laminate material protruding from the surface. These wicks are a potential pathway for moisture ingress through the laminate system to the steel surface, and all wicks must be removed. The removal of wicks can be done via abrading or sanding, and it is noticed that wicks are a more common problem in colder climates. It's very important that all wicks are removed. The sanding process to remove the wicks should be a relatively quick process and does not require a lot of pressure applied to the material. It's just a process of removing the wicks from the top, as there will be a further gel coat applied after this. These photographs show typical before and after. On the left hand side, you'll see a glossy surface prior to sanding, and on the right hand side, you'll see a more matte surface post sanding. The final step in the coating system is the gel coat. The gel coat's used to seal the laminate system, and around about 350 microns or 14 mils of interline 984 is typically specified. This slide shows two photographs of the complete Matcote system at a typical system d.f.t of around about 1600 microns or 64 mils. The importance of the quality control person in the application team should not be underestimated. Checking wet film thickness readings as the application process is underway can ensure that any remediation can be done immediately and easily. Any remediation post-cure is a much harder process. However, taking d.f.t readings is a good way of ensuring that the full system is applied correctly. We've now covered off the main areas of the application, so we'll take a look at some of the technical inspection and quality control procedures that should be in place. So in this section, the first thing I want to look at is holiday detection. Defects in the interline 984 dry film can be detected using a high voltage holiday detector set at 100 volts per 25 micron or 1 mil of dry film thickness. Our advice is that holiday detection should take place before the gel coat is applied. Holiday detection is basically a power supply within the detector which generates a high DC voltage which is supplied to a suitable probe. As the probe is passed over the lining surface, a defect is indicated by a spark at the contact point with an audible alarm in the detector and a visual alarm in the probe handle. All defects must be correctly repaired prior to putting the lining into service. And because we suggest that the detection is done before the gel coat is applied, this ensures that there will be no issues with the finished system. During the application of the Matcote system, it is possible that areas which appear dry may be seen. This phenomenon is typically caused due to one of two reasons. Firstly, the over-application of fibres or the under-application of resin, and secondly, the incorrect rolling technique. If these spots are caught by the wet film thickness reader or the QC operative and the material is still wet, then it is possible to return to the area and either apply more resin or further roller the surface. If this is not caught until the material is dried, then repair is required, and this is a much more significant undertaking. For that, we need to see the repair procedures section. If the applied material is dry, it is advisable to adjust either the air motor or tip size to achieve a more equal distribution of fibre and resin. During the application of the Matcote system, it's also possible that areas which appear paint or resin rich may be seen. This phenomenon is typically caused due to over-application of the resin or under-application of the fibres. If these spots are caught by the wet film thickness reader or QC operative, it should be checked to ensure that sufficient fibres are being laid to meet the specification. If this is not caught until the material is dried, then repair may be required. For this, see the repair procedures section. If the applied material is over wet, it is advisable to adjust either the air motor or tip size to achieve a more equal distribution of fibre and resin. Now we'll move on to look at repair procedures. If repair is required to the Matcote system, then the problem area must be removed using mechanical tools. Grinding or sanding are suitable methods. The area to be repaired should be removed 50 mm or 2 inch past the outer edge of the problem. The system should be removed back to the primer with a feathered edge, and the full system should be reinstalled. For smaller areas, it is okay to follow these steps. First, apply resin via brush or roller. Then, cut the glass fibre mat or roll, look at the picture to the bottom right, to size and embed in the resin. Then liberally apply more resin by brush or roller, ensuring full coverage of the mat. Follow this by using a ribbed roller over the area to remove any entrapped air and ensure the mat is fully wet out. Next, we'll take a brief look at chopper gun maintenance and some of the plural component spray equipment available. Chopper gun maintenance. When handling and using the chopper gun to apply Matcote, minor maintenance is to be expected. If working at maximum coverage, that being over 600 meters squared per day, the cutter head may need to be replaced 2, 3 or more times. This replacement is normally required as the chopper blades become blunt or suffer damage. When a blade suffers damage or when any blade changes occur, it's good practice to change all 8 blades on the cutter head. When replacing blades, it's good practice to replace all 3 elements. That's the blade, the spacer, and the tensioner or retaining spring. The 3 elements must be replaced in the correct order. When replacing the cutter head, it is critical to replace in the correct manner, as the cutter head has a front and back. The outward facing side has a rectangular notch visible. The inward facing side has a small V-shaped notch visible. The rubber anvil sleeve will also need to be replaced regularly. On the screen you see the Duomix 333 from Wiwa, a plural component pump which has been proven for good successful use with the Matcote system. Other pumps are available from other suppliers such as Graco. As we come towards the end of this short webinar, we'll take a quick look at some of the key elements when applying Matcote. The primary use for the Matcote system is on the maintenance of heavily pitted tank floors. The system can be used at new construction and in other maintenance scenarios, however. The system is based on Interline 984 with glass fibre roving chopped into the resin. As with all tank linings and protective coating systems, surface preparation is key. Critical elements of the application itself include having the right number of team members, keeping the glass fibre roving clean and dry. Remember, if the roving gets wet, you'll have serious issues with clogging in the cutter head. Make sure that the paint is kept moving through the lines as the pot life is short. Keep spare cutter heads close to hand to ensure uninterrupted application and allow maintenance of the gun to be done in the tank on site. Ensure the rolling is done correctly and with a range of roller heads to ensure the consolidation of the material into the resin. And always ensure sanding and removal of wicks is done. Repair and remediation work on Matcote is time consuming and hard work, so make sure it's done right first time and remember the criticality of the quality control operative in the tank. Thanks for your time today, and I hope you enjoyed this short look at the Matcote system.